Okay, cool. Well, hello everybody, and welcome back to the Azure podcast. This is episode number 384, and we're talking about the safe deployment process in Azure with Cristina Del Amo Casado. And this is being recorded today on July 7th, a couple of days past the US holiday. I've got my co-hosts Cynthia and Sajit here today. So what do we have for news, folks, today?
Yeah, I put a couple of items in there, things that I am passionate about. The first is, you'll recall a few weeks ago, we had another Cristina on the show, Cristina Campi, who is the PM for ASE, or App Service Environment, as it's known as. And she talked about the new version of ASE that was coming out, and happy to announce today it's generally available. ASE v3 is generally available. Just to recap for our listeners, this is like the single tenant system version of app services, so there's nobody else sharing your infrastructure. And in this new version, they have reduced the number of endpoints you need to expose, so it's a little more secure for enterprises that are worried about exposing all those endpoints that were previously required. They've got availability zone support now available, and you can actually reduce your cost if you move to ASE v3. They've taken away some of the overhead costs for upgrading your servers in ASE v3. So definitely look at that if that's something that you use or are looking at using. And the second update that I have is something, IoT is another kind of passion of mine, and the form recognizer service is something that has been very popular. It allows users to submit a picture of a form, and it could be a handwritten form or something electronically captured, and the system will then recognize all the fields in the form. But to do that, you have to give it some samples mocked up, and then it takes that, it creates a model, and then you can query the model. Now with this new version where they've allowed you to have it run in a container, you can actually do the form recognition directly on the edge by using the IoT Edge, because IoT Edge runs containers. And so now you can think about the possibilities where that model gets downloaded down to the edge, and you can do it all within your, let's say, your store or wherever you're scanning these things, your warehouse, wherever it may be. You could do the recognition locally instead of having to go back to Azure every time. So this is another nice feature, I think, by allowing to use that form recognizer inside of a container. So those are the two updates I have.
I would say this is interesting because this is sort of further along that path that we talked about last week when we talked about SQL managed instances, right? Being able to run on any cloud, on premises, whatever, because it's running in containers, right? Like, it's neat to see the evolution of these services because we can push them out closer to the edge, right? At that point, which is where people
closer to wherever the customer is.
Yeah.
It may not always be the edge, as you said. Could be running on on premises or whatever.
Yeah, that's fair.
Wherever the customer wants it.
Yeah, so you sort of get the management benefit and the design benefit of the cloud without giving up that closeness and everything that you want. No, that's cool. That's cool.
Does that mean you train your container or train your model first, and then that kind of stays as a set version of your machine learning model, and then you would have to train it again? Like, how does it talk back to Azure?
So the model is then deployed to the container. So Azure will, you previously provided all these samples marked up, and Azure then takes it, does some number crunching on it, and creates the model for you, right? This is the model. It's a standard machine learning model, and then that model file, right, is downloaded to the container. Now the container can do just work on the model file. That's all it needs, right, to do the recognition. Mm-hmm. Everything it needs is local. It doesn't have to go back to Azure to do it. And of course, this assumes that you have a powerful enough IoT Edge device. Obviously, you don't want to put like a laptop there, then the recognition is going to be very slow on your device. But it does give you that option of offloading some of that compute locally to do AI and ML on the edge.
Cool.
Awesome.
Cool. And then now, Cynthia, it looks like your news announcement, could we have timed it any better? I swear to God, to the audience, we did not plan this. This is really fortuitous.
So there's a blog post that came out regarding safe deployment, actually, with AI Ops, and we are introducing Gandalf, which is the code name for this AI Ops service that Microsoft is leveraging. And really the reason why this came about is there are just way too many signals that could come during a deployment of like our 200 data centers in more than 60 regions. And it is impossible for human beings to do anything about it. That I'll probably just be paralyzed by the amount of input you get at any millisecond. So yeah, with Gandalf, you're not only able to look at things at a local level, it actually also has a global scale, and hence the name Gandalf, where he's like overseeing everyone in the world of Lord of the Rings.
Got the connection. I never made that connection. I've heard Gandalf for a long time now. Internally, I never made that connection. So that's
pretty cool. So that is the blog that came out. I reviewed a few weeks ago. So it went out already. Cool.
we timed it just right, Cristina, when we were scheduling you.
You know that.
Yeah, so that's actually it's a good segue, to introduce Cristina. Cristina, if you could introduce yourself and tell us what you do for Microsoft.
Well, so I'm in the middle of all these health signals that we use across Azure in order to gate deployment process, and my team also owns all the tooling and the experience for all the deployments that we do in the core infrastructure in Azure. So pretty cool stuff. Something that we put a lot of investments on, especially with machine learning, AI ops, a lot of improving of the signals, because one of the core things that we're trying to do is to find out whether there is a problem that we didn't detect in testing at the time that we're making progressive deployment. So Gandalf is one of our biggest partners, and they're really fantastic to work with. They've been investing so much on all this anomaly detection, and we keep partnering with more teams to get more and more of these health signals that say, wait, stop, there's something wrong going on over here, start rolling back. So yes, pretty cool stuff.
Yeah, so this all fits into the safe deployment practices world, right? Which is, if you could sort of explain how would you describe SDP or safe deployment practices to somebody who doesn't, has never seen it? Like you and I talk about this stuff all the time, right? This is stuff that we think about in engineering as we're doing rollouts all the time, but how would you describe it to somebody who doesn't know anything about it?
So I would say, okay, let me start by my personal experience, right? I'm a very clumsy person. I remember when I was a kid, my mom would go and say, look where you're going, you're gonna fall. Don't use these new clothes when you're gonna go play outside, you will fall and break them. Make sure that you don't trip here and there. And she would give me all these warnings and try to give me certain protective measures. I will still fall, break my new clothes, and keep having every single summer, I keep having all sorts of problems in my knees and elbows and so on, right? So the safe deployment practices are like my mother, giving all these warnings and protective measures for the deployment. So in this case, Cristina would be the deployment, right?
Yeah.
And so basically what we do is to know that whenever we are going to make any changes in Azure, even if we test, we try to cover all the scenarios in advance. That's one area where we have been investing a lot and we continue to do that. There's always a certain risk, right? Because there's so many scenarios. Azure is so big. There's so many moving pieces that we just embrace the fact that there could be a problem that we haven't detected early on. And so what we do is to put a series of policies and practices, and we're doing more and more of that enforcement in order to, in case that we actually find a problem that we didn't detect in testing, try to minimize as much as possible the reach of that problem, right? And so there's a few rules that we follow, or policies that we follow. First of all, we start small when we start deploying, when there's more risk. And as we are gaining more confidence, we go and increase the scope of the deployments. And also the first phases in which, so we deploy in phases, and each phase is bigger, bigger, bigger. As we gain more confidence, we go and reach out to more machines or more clusters or more services. And so the early phases that we have, they're also internal phases so that we can get at the scale some of these scenario coverage. And then we start moving to general production, where we can also get more signals from the workloads. So that's one of them. Do it in phases, assume the risk, and then enforce these phases. That's what we're doing. And then the next thing that we're doing is actually leverage a lot of expert systems like Gandalf, right? Which is, okay, this is not just about going slow. If you're going slow, it's like if you're driving your car and you cover your eyes, you're gonna crash, right? So the signals are like our multiple eyes, and we have eyes all over the place as much as we can, and we keep trying to add eyes, which are those health signals, right? And what we do is to basically have all of them injected into the deployment system. So when there is a problem, we were like, wait, stop the car. And then at that point, we go and stop the whole deployment. And so those are some of the two key things. Do it in phases, start small, keep increasing the scope, listen to all these signals, get all these expert systems that are in machine learning, AI ops, anomaly detection, all these type of things. And then at that point, we stop the things when we see that there is a problem.
Cristina, I'm curious, now that a lot of them seems like is part of the process, what is the human involvement, and what is like human involvement in the process of deployment? Do you still approve, or does it have to just follow the flow and then it'll get deployed?
So first of all, you were talking about the size of Azure, right? So you can imagine that we don't go approve every node and every cluster or every service, because it will be like a total clicking, click, 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 click. So that's not how it works. But every time we do have a release for compliance reasons, we do have to have an approver, right? So you have a submitter and an approver. So those are what the release managers do. And then those are going to be saying, okay, this is the release that is going to be orchestrated across all of Azure, right? And then we have orchestration systems that are imposing all these SDP rules, right? And so they basically go and do a check-in or click a button and say, okay, submit now. And then the system is going to go and take everything in multiple phases. So the human involvement is mostly not on doing all these operations, but it's mostly being there for when there is a blocker, right? So if there is a problem, then it gets raised, and then they can go and look into what the blocker is. Or of course, if we stop the deployment, they have to go and look, oh my gosh, what happened over here, right? So that's the type of things. And I'll tell you, sometimes that we have still more involvement because we tend sometimes to be a little conservative. Sometimes we stop things and then they look because we have some signal that could be a warning, and then nothing happened. And then at that point, then maybe they go and resume after investigating. So you can see there's involvement at the beginning for the approval of the release. We need that for compliance. And then as the releases progresses on its own, not without click, click, click over here, but just the system does it automatically. Then is when they get involved when there is a problem. And we continue to evolve on all this automation so that we can actually move faster, but still be safer, right? That's why all this work that Gandalf is doing, all this AI ops, we're hoping that by enhancing all of these signals and all of these models, we can actually be able to deploy and move faster, but without compromising safety, right? Because at the size of Azure, when we have a problem, even with all these measures, the problem can be pretty big, right? And so that's a continuous journey, and we've been having this journey for years now. I started working on this about 4 years ago, and there were people before me, trust me, right? And I can see myself here for another 4 or 5 years, right? So there's a lot of work that we continue to make.
Cristina, when I was listening to you, what you described as for the deployment process, I'm trying to correlate it to the deployment, let's say our customers may do when they deploy their own applications to Azure, right? And they often use something like a blue-green deployment methodology, where they'll put a small piece of the infrastructure is updated first. Some ratio of the traffic may be directed there, maybe first, and then you try the new version before they roll it out. How do you get those signals that users like outside of Azure users who happen to be using the new deployed version are not having any problems? Like, don't you have to wait for some signal from them as well to know that, hey, the deployment is going well so far?
So actually, that is a really good question, and you almost asked me 2 questions there, right? So first of all, blue-green deployment. So in Azure, because the architecture of services are so different, we have multiple mechanisms that we use for safety. Some of the services do use these blue-green deployments. Some others actually deploy in slices. Some other services we just deploy and look at the signal. So we have to use a combo to adapt to the service characteristics. Blue-green deployments is something I completely recommend our customers to follow if they have something like an active service or an active passive service. It's a really great way to do it. You basically deploy in one of the instances. Look at your signals. The important thing is you need to have some signals, whether you look at them manually or you have it automated. Automated is my preference, obviously, but you have to look at them and then flip over. And that means that if there is a problem, you can always go back to the last known good within a period of time that we call it baking time, right? So completely recommend it. Now, in our case, we have, when we're deploying, you're very right, Sujit, that we have to also figure out, as we are deploying, are we making any changes that are affecting our customers? And so we use a combination of things. I will let you know that for the time being, most of our signals are internal, but we have started to actually use more external signals from the customers. And we want to actually move more in that direction. So we have a ton of telemetry. And so whenever we see, for example, that some VMs are virtual machines are becoming unresponsive, or we're seeing a restart or things like that, those things we see. We're looking into traffic, some of the performance metrics. And so some of these factors can tell us, oh, there is a problem. And we can do that with our signals. And in the cases of some of our services, like, for example, early on, Sujit, you mentioned that you had Cristina, the other Cristina, Cristina Compi, a few weeks ago. So, for example, if web app service is deploying, right, they're measuring the SLAs for their customers, and if they're seeing a drop, they can use those signals. Those are signals that are based on traffic that the customers are issuing. So we have that. So there's definitely signals that we measure, which is measuring the customer experience, right? But one of the things that we're trying to do more in the future is to have some other ways to collect signals from the application from the customers. And that's even more important when the customers have applications in virtual machines. We don't have visibility of what's happening inside the virtual machine. So the first team that started to invest on that with us, in partnership with the deployment systems, is actually the BMSS team. You know, we have been investing a ton in a virtual machine scale sets, with some of the latest things being the virtual machines scale sets flex, which allows you to basically have a much bigger scale and all that. So all the updates that happen in those virtual machines, if you're trying to do a guest OS update, some updates from other components in the VMs, not all of them, but some of the ones that we control, we have a hook over there to get signals back from the customers, from their application, right? And we consume those signals in our central deployment system. So if we're doing a guest OS update in those virtual machines, or updating some extensions in those virtual machines, and we get information back from the customer saying, oh, there's something wrong for me over here, we stop and we can even start some rollback. So we started out with the virtual machine scale sets, which is one of our biggest bets, right? And then we actually have plans to start extending that to get other type of signals for more of our general deployment. So it's a step in that direction, because we actually, to what we were saying, the more signals we have, the less blind we are. We have some system signals, but if we can complement that with information from our customers, that is really helpful. And one of the work that we're doing with the IOPS teams, and we have to continue investing in, is how do we eliminate the noise, right? Because some of the signals could be very noisy, and you know, we have to basically embrace that as well, and then make it part of our plan and design. So you should see more of that coming in the future.
It sounds like, when I hear you describe this, Cristina, that SDP is, I mean, there's certainly a tools element to it, right? There's Gandalf, there's our deployment systems, there's the health signals you're talking about, but it's more about the philosophy
Yes.
And then having a central, like a central vision that we want to do as an organization, and then trying to put all the pieces in place to make sure that happens. Because this is like the thing that I talk to customers about periodically is, with the exception of some of, our competitors who do similar work, there has never been, software and deployed at the level of complexity and the scale at which Azure runs these days. Like, this is new stuff. So there's folks like you that are sitting around time thinking about, how do we get better all the time? That's the practices piece of that.
Yeah.
Is that the right way to think about this?
Yeah, it's definitely both philosophy and tools that will facilitate putting all these guardrails and policy in place and automate the heck out of it as much as possible so that we can do it at the scale. And the way we're looking at it, to what Sujit was asking is, for example, like you can see that in signals from the customers is democratize it, right? Like really, the first part of it, the philosophy is, there's so much out there you don't know, right? So embrace that, have an open mind, right? And try to get as much as possible to contribute to tell you whether there is a problem or not. Give enough time for things to bake so that you can collect enough signals and then move to the next phase. That's kind of the philosophy. Then, of course, you have a lot of automation that you have to make at the scale of Azure, right? Even I would say some of the principles that we use, they're very valuable for many of the customers, even if it's at the smaller scale, right? Mm. Always test as much as possible in advance, right? Have as much coverage and assume you're gonna miss things because we're all human and we miss things, right? There's so much going on. And then, yeah, figure out, okay, how do I have some signals that will tell me there is a problem? Start small, look at the signals, seems like it's going okay. Go to the next step, look at more signals, like ask anybody to give you signals that will tell you there is a problem. Have enough time for traffic patterns to happen so that you can, make sure that things are okay. And design how you're going to be doing the rollback, how you're going to recover in a case of problem. Can you automate those type of things? Those are the type of things that we think about every time, right? Minimize the scope of the problem if there is a problem, have a plan to roll back as soon as possible. And even when we actually practice, sometimes we make mistakes and then you have to learn from it. That's the last part. Learn from it. So next time, hopefully you learn from it and you have another plan, right? Because this is the continuous learning for all of us.
Cristina, early on with the I think it was with the cloud services, we were introduced to the concept of update domains, right? Apparently, that's one of the features where, I guess if the underlying hardware had to be or the software had to be updated, there was enough hardware in there to move things around. But customers can often delay some of these updates, right? They can say, I don't want to take the update right away. There's maintenance windows now that are available. And so when you're rolling out new software, like how long does the whole process take? With all of these variables in there, like how do you? Is there a way you can put a start and an end time on the update, or does it just take some unknown amount of time for the entire update to finish?
Well, so we have multiple variables here. That's a complicated, you just gave me a very complicated question, very, very complicated. And I will have to tell you, things had to evolve. We had no choice but to evolve those things because we do have actually a commitment to the customers to deploy certain fixes or critical security updates or even in some cases features that they're asking us to deploy, right? Across all Azure in a specific amount of time, right? And it varies actually. It varies per service, it varies per components. We don't have anything that is static, right? Some of the things that are more complex move slowly. Some of the things that are, more high level, they can move much faster. We have some releases that complete in a week. We have some releases that can take 1 or 2 months to complete across all production, right? And so we do a combo of those. So first of all, you were asking about this update domains. I get that question very much. Initially, when Azure started for cloud services, we did have update domains and full domains. They're still there, right? The commitment that we have is that if we're going to make a rebootful update, like a really rebootful update, we will follow update domains, right? However, the majority of the changes that we do in Azure, number one, they're fully transparent. You just fly, you don't even know. I mean, we have hundreds of updates that are going through. You wouldn't know, but if you look into all our telemetry, you're like, whoa, what's going on? There's so many changes. They're good changes. Most of them are, this is because we're following more like DevOps model in which we have small changes, right? That are continuous changes. And that's good because that means that we can bring some of those fixes faster. But that also means there is a lot of changes. This is why automation is critical, right? And so now when we deploy, in order to be more predictable for core infrastructure updates, I'm not talking about services like maybe IoT or machine learning, but when we deploy in our clusters, right? Basically our core infrastructure of the fleet, we don't go update domain by update domain. When we do update domain by update domain, we have to follow something called graph coloring, which can actually have a huge tail. It could be days in order to finish. And now, because we're doing all these things at the availability zone level, not at the cluster level, so we can support the MSS Flex, the graph coloring is massive, right? So it would be really taking too much time to do all that. So we actually have a more predictable model, which is we follow blocks. It's mostly associated with racks that we coordinate across the availability zones, right? And we sequence availability zones. So we go to regions, we sequence some of the regions. Within a region, we go availability zone by availability zone. And within availability zone, we coordinate across different clusters and racks. And so we update that. And as I said, fortunately, everything pretty much is transparent, but we do have some updates that have some blips and stuff like that, right? Most of these updates, again, they are transparent. We send notifications to customers that have been subscribed to what's something called schedule events. So a few minutes in advance, we go and say, hey, we're going to be updating here, and this may have a blip or stuff like that. And then there could be a prep work. And again, all of this is coordinated, and then we proceed. We have a certain number of customers, to what you were saying on plan maintenance, that they wish to control 100% of the updates that occurred in the hardware that they own. They tend to be customers that own a whole node or a whole host machine, and they place their VMs over there. They typically use something called Azure dedicated host, and it's almost having their own property there. And because it's their property, they want to say, this is when I want all my updates to apply, right? And so they have APIs to do that. And at that point, they can take maybe a month to accumulate updates and update them in their node, and then do it at the time when they can plan the maintenance and so on. I would say that gives more control, but that also requires extra effort from the customer, right? We're looking into scheduling and stuff like that to make it more easier for them in terms of the experience. But there's a little bit more work. So I would say only for those cases where customers need that control, they should do it. Otherwise, it's easier to just let the platform go through. So we have the combo of people that are going to be receiving the updates under the covers in this coordinated manner, sequencing availability zones, clusters, and so on, so that we don't go and bring them down completely. That's why we need to have all this coordination. And then others that want the control, those ones actually can take maybe a month or sometimes more than a month to apply the updates. We don't recommend it, that they take more than a month. Why? Because they're missing reliability updates potentially, or features, or even security updates, right? And so that's why it's not recommended. Now, one of the things I would say, if we actually have a very critical update, like a critical security update, we have the tools to enforce it, but we tend to only do it as a last measure in case that customers have control. I don't know if I answered your question, did I? Okay, good.
I guess I get the honor of asking the last question. How do you test this whole system when it needs to be used at such large scale?
Well, first of all, we do have actually deployments that we run ourselves to self-measure. We call this our hello world, which is pretty much like an empty payload that we do and see how we see it, where we have to make improvements. So we have that. And then also we have very vocal customers, right? These are internal release managers that when something, they want it to work better, if there is an issue that we didn't detect through our own testing, they do tell us. But I mean, obviously, with that, we do have for our systems our own testing, right? Like with the same as what we ask everyone else, right? And then lastly, again, we self-measure ourselves. We have our own validations that go through the whole fleet transparently, and we're like, ooh, this is where we find another area to do better, right? So that's how we do it.
That's great because just a sign. It's a little plug for our audience. We all learn stuff from these podcasts, right? We talk about it internally. We all learn things even when we show up as hosts. I saw a Hello World deployment last week when I was looking at some platform data, and I went, "What the heck is that?" Now I know. This is great.
It is an empty payload that we orchestrate through the fleet, including our national clouds and so on. So it goes everywhere so that we can measure how long it takes end to end. Do we actually, how are our health signals working? How is like basically all of that? And it just goes through. And sometimes we also go and do what we call a fast lane, an expedited rollout, so we can see that works, because sometimes we have some of those critical things that have to bypass and jump in front of the queue. So we also have those things validated too. Mm-hmm.
That's great. That's awesome. That's my learning for the day. So this was awesome, Cristina. Any sort of last thoughts you want to leave the audience with?
I would say that for anyone that has their own services, which is a lot of our customers, and they also have to do their own releases, the practices apply to. And for us in Azure, they have work. We have a lot to learn still, but always again, test, phase your rollouts so that you can make sure that, again, you don't basically go into a situation where everything is down. You can use maybe some of these blue-green deployments or deploying slices, and invest, even if it's just a little bit, on some of the signals. Ideally automate that, because there's a lot of tools out there. You have that possibility if you're using AKS or Service Fabric. A lot of our tools actually enable you to do a little bit of this splicing and progressive deployment. And if you're using VMSS and VMSS Flex, which I completely recommend, then look also into giving us the signals of, wait a second, something's going wrong here, and give us the signals, because we consume them and use them for your updates too.
That's great. Well, no, this is awesome. Thank you for coming on, Cristina.
Thank you for inviting me.
This is a much happier conversation than you and I usually have, right? We're usually on the other side of when something goes wrong. But this is great. Sujit, Cynthia, any last words for the audience?
I mean, I love how they, Cristina and her team are planning to expose some of these learnings, right? So our customers, I think that's the key thing here, because our customers go through the same pain as they're going through. Of course, Cristina deals with it at a 1 billion times scale compared to our customers, but everybody has that same pain. So thanks for sharing all of that.
Thank you for inviting me. It was fun.
Great. Thanks, folks. See you next week.